All right, direct variation. Lesson 5.2 is direct variation. Direct variation is a relationship that can be represented by a function in the form y is equal to kx, where k is not 0. So we're looking for equations that are written in the form y is equal to kx, but k cannot be 0, because if k was 0 and you multiplied it times x, you would get 0. So the formula for direct variation is y is equal to kx. The constant of variation for direct variation, k, is the coefficient of x. So k is the number in front of x, and you can find k by taking y divided by x. All right, so k is equal to y divided by x. To determine whether an equation represents a direct variation, solve it for y. If you can write the equation in the form y is equal to kx, then you have a direct variation. Now, y is equal to kx it's not divided by anything, it doesn't add anything, it doesn't subtract anything, it's just y is equal to kx. All right, so problem 1 says, does the equation represent a direct variation? And if so, find the constant of variation. Well, if I solve this for y, which is what this said, I'm going to divide by 7. And I have y is equal to 2/7 x. Is that a direct variation? Is it y is equal to a number in front of x? So yes, this is a direct variation. And k is equal to 2/7, because k is always your coefficient of x, and it can be a fraction. All right, let's solve this one for y. Subtract 4x, so I have 3y is equal to negative 4x plus 8, and divide by 3, and I get y is equal to negative 4/3 x plus 8. Is this a direct variation? This is not a direct variation because it's not just y is equal to negative 4/3 x. If it had just been this part, it would have been a direct variation. This plus 8 makes it not a direct variation. It can only be y is equal to kx. So the plus 8 makes that not a direct variation. All right, problem type 2. Suppose y varies directly with x. This is your clue that you're dealing with direct variation. That makes you immediately think y is equal to kx. When I see suppose y varies directly with x, I should be thinking y is equal to kx, because that is a direct variation. Suppose y varies directly with x and y is 35 when x is 5. Okay, stop right there. Plug that in. Y equals kx. Y is 35 when x is 5. All right. What direct variation equation relates x and y? And then what is the value of y when x is 9? All right, so to write the equation, I have to find the constant of variation. So I've got to solve this for k. Well, they told me y is 35 and x is 5. So I'm going to solve for k by dividing by 5. And I get 7. All right, now that I know that k is 7, I'm going to plug it back into the original equation. Y is equal to 7x. This is my direct variation equation. Now, so that's the answer right here. What direct variation equation relates x and y? Y is equal to 7x. Now it wants me to find what is the value of y when x is 9. So I'm going to solve y is equal to 7 times 9. Y is equal to 63. So the value of y when x is 9 is 63. So first you have to take the equation y is equal to kx. You have to plug in the x and the y that they give you to find k. Then put k back in the original y is equal to kx. Here I got y is equal to 7x. Then find the value of y when x is whatever number you're given. All right, let's work another one. Suppose y varies directly with x. Here's my clue that I'm thinking y is equal to kx. Y is equal to kx. And y is 10 when x is negative 2. So y is 10, x is negative 2. Now I'm going to solve for k to find my constant of variation. So that means I have to divide by negative 2. So I get negative 5 is equal to k. Now when I plug that back in, I have y is equal to negative 5x. This is my direct variation equation. Y is equal to negative 5x. All right, then it asks me what is the value of y when x is negative 15. So y is equal to negative 5 times negative 15. Two negatives are going to give me a positive. So 5 times 15 is 75. All right, graphing direct variations. Direct variation equations always go through the origin at 0, 0. So the first thing when I see that I've got a graph of direct variation is I'm going to put my first point at 0, 0. And then 2 is the same, that's my constant of variation, and that's the same as the slope. So this is 2 over 1, which tells me I'm going to go up 2 and over 1, up 2, over 1, up 2, over 1. So that's how I graph y is equal to 2x. All right. Graph y is equal to 1/3 x. I know this is a constant of variation, a direct variation, and my constant of variation is 1/3. Direct variation tells me I start at 0. This is the same as my slope, so I'm going to go up 1 over 3, up 1 over 1, 2, 3, up 1 over 1, 2, 3. Okay, so use the slope to graph it just like you would anything else. Okay? Always graph 0, 0 first. All right, let's graph negative x. Well, this is understood to be a negative 1, right? My first point goes through 0, 0, so this tells me that my slope is negative 1 over 1. So I'm going to go down 1 over 1, down 1 over 1, down 1 over 1. So this is what the graph of y is equal to negative x looks like. All right, graph y is equal to negative 1/2 x. Direct variation, so my first point is at 0, 0. My slope is down 1 over 2, down 1 over 2, down 1 over 2. Okay. All right, so in summary for direct variation, y is equal to kx, where k is your constant of variation. The graph of a direct variation equation is y is equal to kx. The graph of a direct variation equation y equals kx is a line with the following properties. It always passes through 0, 0, and the slope of the line is always k. So when you're graphing direct variation equations, you always start at 0, 0, and you use k, the coefficient of x, for your slope. Now my suggestion to you would be to go back and watch this video and watch these examples as many times as you need to until this is just second nature to you, till you understand everything about y is equal to kx and direct variation and the constant of variation.